Hello everyone, my name is Manuel and today I will talk about my research on assessing risk factors for the incubation period of COVID-19. First of all, I want to introduce quickly about the COVID itself. In December 2019, there was a cluster of pneumonia cases of unknown etiology detected in Wuhan, Hubei province in China. The cause was identified as a novel coronavirus, SARS-CoV-2, and the disease was later designated as coronavirus disease 2019 or COVID-19. COVID-19 has become a global pandemic, infected more than 100 million people and killed more than 2.5 million people all over the world. Knowing the incubation time, which is the time from the infection to the symptom onset, can help us control the pandemic and set up proper quarantine procedures. Our objective is to evaluate the association of some variable with incubation time of COVID-19. The findings could provide some guidance on shortening or lengthening the standard quarantine duration of 14 days for certain subgroups and help better control the pandemic. In our study, we investigate 463 Wuhan exported COVID-19 cases confirmed at 14 locations in and outside mainland China. The cases stayed in Wuhan and left before the travel ban on January 23, 2020. It is assumed that the cases were infected during their stay in Wuhan, thus called Wuhan exported cases. The dataset includes 3 key days: begin stay in Wuhan, end stay in Wuhan, and symptom onset, which are abbreviated shortly for BEMS respectively. The data also include variable age with the median is 46 and the interquartile range from 33.25 to 56, and the variable gender as well, with 213 female and 250 male. We considered 3 different methods for incubation period using regression analysis under Koch proportional Hazard model to evaluate the association of age and gender with the incubation time of COVID-19. The first one is the method of midpoint imputation for infection time t, and then we estimate the incubation time as S minus t. The second method is to treat the incubation time as interval sensor, that we know the infection time for between the lower bound equal to S minus E and the upper bound equal to the S minus B. And lastly, is the method of multiple imputation, that we impute M infection time T and then we estimate the incubation time by S minus T. And I will talk more details about every single method in the very next slide. For the method of midpoint imputation for the infection time, we need to compute the midpoint equal to the time begin stay in Wuhan plus the end time stay in Wuhan divided by 2 for 459 observations. Note that 6 cases have not shown the symptom of diagnosis and thus presented as S, and we estimate the incubation time equal to S minus T. We employ the Koch proportional Hazard model, which is very commonly used in the time to event data. The conditional Hazard function of the incubation time given the coverage X is equal to S0t times the exponential of beta times coverage X, where S0t is the unknown baseline Hazard function and beta is the regression coefficient, also represents a log hazard ratio. Besides, the Kaplan-Meier method or non-parametric method is used to estimate the survival probability on the observed survival time point by this formula. And the results are obtained by using the function Koch-pH and fit in the package of survival in R. While gender is not significantly associated with the incubation period with p-value 0.85, age and age group do associate significantly. The hazard ratio of age and age group are also greater than 1, meaning that for the older group, coverage F2 has higher risk or shorter incubation time than the younger group. And this is the Kaplan-Meier survival estimate for gender and the Kaplan-Meier survival estimate for the age group. The survival probability is extremely overestimated since the survival probability at 14 days about 0.73 in general, while it is nearly 0.75 for the younger group, or I can say that 75% of people had the incubation time after 14 days. Furthermore, from this plot, it suggests that the incubation period is unlikely to happen uh, up to 40 days. This bias is due to our naive approximation because the midpoint of time between Steinfurhan and the time and Steinfurhan is not a good estimator since it has no statistical property to justify the survival analysis. So we treat the bias by employing the method to treat incubation time as interval sensitive. Let's TI denote the incubation time for 434 observations, and TI is not exactly observed but known only to fall within an interval of L and U. If T is right sensitive, then the upper bound will be equal to infinity. One more time, we will fit the cost proportional Heather's model to the interval sensor data, like in the method 1. And the results are obtained by using the function unirect in the package of insane in R. Neither gender or age group is associated with incubation time of COVID-19 with p-value are greater than 0.05. However, we want to look at more carefully in the estimated survival function for incubation periods based on gender and based on age. The incubation period is also overestimated with the survival probabilities after 14 days. Our standard quarantine time are too large and even much larger than some literatures have found. It is 0.25 in general, while the 0.35 for group of young people. Since we are not carefully taking account for the truncation, so this method is not really efficient at all. Um, we consider the last method, uh, which will address the naive approximation in the first method and the limitation in the second one, that is the multiple imputation. We impute the missing value infection time now to fall within PNE using an exponential distribution with the probability density function PDF and the cumulative density function CDF derived from the probability of contracting the virus in Wuhan respectively by the formula with the lower FT is the PDF and the upper FT is the CDF. We do the probability integral transform to transform variable from uniform distribution into exponential distribution to find infection time t by this formula, and then generate m infection times from the distribution restricted to the interval B and E. For each imputed infection time t, we calculate the incubation time as s minus t and perform the regression analysis incubation time under the Koch model. We do step by step by finding the final coefficient beta and the final variance sigma as follows, and then find the Breslau estimated lambda t, which addressed in the Lean paper 2007, and estimate the survival probability of correct act where s t given act equal to the exponential of negative lambda 0 t times the exponential of beta times the coverage act. And this is the result obtained by this method. Again, there is no association between gender and the incubation time. However, this age and age group is considered to associate with the incubation period. 95% of confidence interval of hazard ratio for the age group is 1.002 to 1.532. And this is the probability of incubation time greater than 14 days using the estimate survival function for each group. Looking at the figures, the survival probability at 14 days is about 0.1 in general. It's 0.1 in general. While it is about 0.15 for the younger group, or 15% of young people having the incubation period after 14 days, which suggests that the young group should have a longer quarantine period than any other subgroups. So in conclusions, we have proposed three different methods to evaluate the factors associated with the incubation time of COVID-19. The midpoint imputation method suggests that younger people seem to have longer incubation time, while the incubation time for male and female has no significant difference. The interval censoring method indicates neither age or gender is significant. Both first two methods have some limitation. The former is biased due to naive approximation of infection time using midpoint of BME, while the latter is not efficient because it does not fully utilize the available information on infection time. The multiple imputation based on exponential distribution is intended to address this limitation and truncation of our dataset. This method suggests that younger groups should have a longer quarantine period. So that's it. Thank you for listening.